So hello students, today we will study zeroth law of thermodynamics. In this diagram, we can see that there are three systems, system A, system B and system C. Now A and C are separated by adiabatic wall, which is red colored. Okay, we will draw it here. Adiabatic wall. Now zeroth law states that if A and B and C are in thermal equilibrium, A and B and C are in thermal equilibrium, then A and C are also in thermal equilibrium. Okay, we will write the statement for the zeroth law of thermodynamics. It states that two systems in thermal equilibrium with third system separately are in thermal equilibrium with each other. Means A and B and C are in separately equilibrium, then A and C is also in thermal equilibrium. So we will move to our next point, which is heat, internal energy and work. So what is heat? First we will study what is heat. Heat, we can say that heat is the transfer of thermal energy. Means what? So a short diagram. Let's suppose if this is the beaker, we give heat to this beaker. What gives heat? Okay. Now after some time, the water in the beaker will start to boil. Means what? Heat given to the system. Heat means what? Thermal energy, transfer of thermal energy, which transfers by this burner. The burner transfers thermal energy to the water. So water gets heated. Its the thermal energy is increased and it starts boiling. In simplest language, we say this is the in statement. We easily can write that heat is the transfer of thermal energy from one system to another. Okay. Now next is internal energy. In this diagram, we can see that this is a substance. This cube is a substance. This substance has infinite number of particles. In these particles, every particle has kinetic energy. Kinetic energy and potential energy. What type of kinetic energy? First is, let's suppose this is the molecule which vibrates about its mean position. Means for some time it goes to left, after some time it goes to right. This is vibration. It vibrates about its mean position. Another is what we call as kinetic energy. Mean this, the particle is moving from one point to another point, A to B. A to B means particle is traveling from A to B position. Then it also have kinetic energy. Okay. And the potential energy. Potential energy is due to interaction between two molecules. Suppose there are two molecules, one is positive, one is negative. Then they will have force of attraction. If both are them are positive, then there will be force of repulsion. This creates potential energy in that molecule. So internal energy is nothing but the addition of potential energy and kinetic energy. Okay. I will write the statement for internal energy. It is simply the addition of potential and kinetic energy. Now, in thermal energy, internal energy is denoted by capital letter Q. Okay. So, how it is related to thermodynamics? Let's suppose a system. In this system, a beaker filled with water is placed on a burner, and inside a beaker we placed a piston which is connected to a weight via pulley. Now here we can see that if heat is given to the system, this is heat source, heat is given to the system means water gets higher temperature or water gets thermal energy. So due to this thermal energy, internal energy of that water gets increased. Okay, and some part of heat is converted to the work done. Means what? Let's suppose 10 unit of heat is given to the system. Then system absorbs about to say 7 unit absorb for increasing its internal energy. The remaining 3 unit of heat is used to push this piston. Okay, to push this piston upwards. Okay, remaining 3 unit of energy. So from this diagram we also study our next point, which is work done. So here we can see that system is doing work on surrounding, means here system is water and it is doing work on surrounding. What is the work here? The work here is that the piston gets pushed outside. This is the work done here. So from this diagram we understand what is heat, internal energy and work done. Okay, so now see that total heat given to the system is 10 unit. Okay, internal energy used up 7 unit, then work done used up 3 units, means 7 plus 3 equals to 10, means given heat is always equals to internal energy plus work done. This is our first law of thermodynamics, which we are going to study in our next video. So hope you all understood what is zeroth law of thermodynamics and heat, internal energy and work done difference. Okay, thank you.